Okay, hello class. Good to be with you again. On this last segment, I want to hit these other properties of distributions and data sets with box plots. So an outlier is basically an extreme data point. An outlier is not necessarily a point that doesn't belong in the data set. Again, it's simply one that's extreme. In fact, if you have an extreme data point, it's more valuable than one that's near the average because it occurs less frequently. Percentile is simply the number that designates a certain proportion of the data. So if you have the rectangle, let's say from the die 1, 2, 3, 4, 5, 6, then this number right here turns out to be the number 1.5, and we can call that x 1/6 or 0.17. That is the number that's going to cut us off here with 1/6 of the data, which is equal to 0.17 or 17% of the data. If you go over here, this is the number 2, this is 3, then this number here is 3.5. That's going to be the x.5, which is the median or the 50th percentile. Okay, knowing how percentiles work, I've got a few other examples here that you can read through. Percentiles give us the key piece that we need to create box plots. So let me erase this stuff here and set up a box plot. This is the dull and generic box plot. What box plots do is they give us these 25 percentile regions. So I've got 25%, and then I have these 4 regions that are each 25%. The way we mark them is, this is called the Q1, which is the 25th percentile. This is Q2, which is the 50th percentile, also known as the median, as we said before. And then Q3 is the upper part of the box. That's the 75th percentile. The bottom part is the minimum value, and the upper is the max. Okay, now box plots are really good for 2 things. Okay, first thing is they can be used for outlier detection. Second thing is they're great for comparing variables. Now, you could take a single variable, such as heights of UCR students, and then look at height by, let's say, eye color or hair color, which of course shouldn't show anything. Or you can look at multiple variables, maybe heights of males versus heights of females. Okay, you could also call that within. Depends on how you're collecting your data. All right, with that then, let's just do an example here. Okay, in this data set, I have 40 data points, and the data is in gallons that commuters use per week. Okay, now we've already looked at this data set, so how do we get those 5 key numbers? Well, since they're all in order, then this breaks me into the 2 halves. So the median, x50, is going to be the number that cuts me into 2 parts. So anything between 14 and 15 is going to work. The standard way we would do that is x14 plus 15 divided by 2. That's 14.5. Okay. Now, to get the 25th percentile, we're just going to take the median of this half, which is going to be x sub 0.25, that's 10 plus 10. Where do we get that? This 10 right here plus this 10 right here divided by 2, which is 10. The reason is I have 10 values. If there was an odd number of numbers, I'd use the number in between the two. Okay, x.75 is going to be 18 plus 19 divided by 2. That's 18.5. Okay, so those are my values here. We've got 14.5 as the median. 25th percentile we said is 10, 75th, 18.5. Maximum, of course, is 30. So we'll put the 30 down there. Minimum is the 3. And we can create that box plot. So let's go ahead and actually we'll look at it. There it is. Notice that the 30 is up here. This guy is that 18, 14.5. Yep, looks about right. 10 looks good. Okay, and the 3. Got our box plot. Okay. Okay. Next, I'd like to show a real example of a box plot that's more useful. And I'm going to take this from a consulting job I did on NASA's Deep Space Network. Little bit about the network. Here's their website, and there are 3 sites around the world located approximately 120 degrees apart. One of them is in Southern California, one is in Madrid, Spain, the other's in Canberra, Australia. And what this does is it allows, no matter what rotation the Earth is, for signals to be sent and received 24 hours a day. Okay. PowerPoint here. I did not wrap up the example with the basketball team, so let me just hit that real fast. Notice here that the range for the NAIA school, 78 to 72 inches, is only 6, whereas the Eagles, whom we knew had the height advantage, is 17. That's a signal, and when the standard deviation is calculated, these guys are only 2.5 inches on average away from their center, the mean, whereas the Biola Eagles are 6.25 inches away from their average of 76 inches. So larger standard deviation, greater height variation, greater advantage on the court. Now back to the example here. This is me and my family at the center. Here is us near the largest antenna. You can see that this thing is massive. The top of that guy up there is 70 meters across. This thing is absolutely remarkable. Okay, now onto the data. Let's see. On this box plot here, here's the Australia one. This one is Goldstone, which is in SoCal. And then this is the one in Spain. Okay, right here, affected data minutes. What this is the time total per, let's see here, per transmission attempt that there is a problem with communication. Okay, now what we can see is looking at these medians, median, that they get slightly lower from Australia. SoCal's a little bit lower on average, Spain's a little bit lower on average. Okay, that's one thing. Whereas the variation, you can look at this middle 50% of the data, that's called the interquartile range, and it gets bigger and it gets bigger. So although the average is going down from Australia to SoCal to Spain, the amount of variation is going up. And these single points here, why does the whisker not go all the way to the highest point? It's because those are flagged as outliers. And what we do is we take 1.5 times the IQR, and there's the interquartile range, and you add that onto this point right here. And just visually, it's going to be something like that. If the value of that is below any points, then those points are no longer included in the whisker, but they're singled out as potential outliers. So that's all they are, is just potential outlying points, and they're demonstrated as such. So this gives some insight into the data collection of these 3 sites for the deep space network using a box plot.